Okay, so today I wanted to go over the solution to your free response problem. Part A asks for the relative maximums. So I'm sure most of you just said, okay, relative maximum, I know what that is. There's one there, and there's one there. Oh man, I had a cool color. Hold on. There we go. I wanted to go pink today. So you said, all right, there's a maximum, there's a maximum. No problem, I got that. And we gotta go skinny so we can read it. And then if they wanted minimums, that's there. Easy. And here, do we count this a relative minimum? No, I remember that. You can't count that a relative minimum because there's nothing to the right of it, right? For it to be a relative max or a relative min, it has to have points. It has to be lower or higher than the points to the left and the right. So, okay, no, this can't be a relative min. It could be an absolute min if it was maybe down here, if the graph continued and went over here. So endpoints, remember, can still be absolute maxes and mins. They just have to be higher or lower than everything else on the graph. In this case, that's not what we have. So maybe you went, okay, no, that's not a min. And over here at -5, that's not a min. So I got maxes, mins. Inflection points right here. That's obvious. That's an inflection point right there. It goes from concave down here to concave up here. All right, no problem. And then you came over here and you say, well, this is tricky because it's a straight line. Is a straight line concave up or concave down? Is it either? I don't know. And maybe you looked it up. According to geometry, there's a geometric definition that says that technically any straight line is concave up. However, if we're looking at our calculus definition, something is concave up if the second derivative is positive. If you have a straight line, it means it follows the form y equals mx plus b, for example. So let's just give a random number, a random equation. If we take the first derivative, and if we take the second derivative, it gives us 0. The second derivative of any straight line is 0. Is 0 positive or negative? No, it's neither. So I would say that straight lines are neither concave up nor concave down. So I would not say anything about that side over there. And then you were feeling pretty good about yourself. You went to look at the answers, and the answers were way, 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 way different than what you had. And then you were confused, and maybe you figured it out. Hopefully you figured it out, actually. The first thing I always tell you to do when you're looking at a graph is to pay attention to what you're looking at a graph of. So I purposely cut that off. Pay attention to what you're looking at a graph of. This is a graph of f prime, not a graph of f. So then you have to go, oh shoot, okay. So if this is f prime, when does f get a maximum when you're looking at f prime? So in terms of f prime, how can we tell when f is at a maximum? Well, f hits a maximum when f prime changes from positive to negative, right? When we're doing our horizontal line test, this is the first horizontal line test, and say we have -3 and 3, and we go, okay, positive, negative, positive, for example. This is just an example. Well, which one's a maximum, which one's a minimum? Well, this one's a max because the slope, remember, the derivative is the slope of the original function. The slope of the original function goes from positive to negative. That means there's a max there. And then the slope here goes from negative to positive. So that means that there's a min there. Okay, so let's just look. Here, it goes from positive is anywhere above the x-axis, to negative, which is anywhere below the x-axis. Remember, the x-axis is like your location, and the y-axis is your value. So when we want to know when is the second derivative positive, we're asking when is the value of the second derivative positive? That's the y. So anywhere above the x-axis, y is positive. Anywhere below the x-axis, y is negative. That's how we get that. So this, at -3, we should have a max. And at 4, we should have a max. And that's because we're looking at a graph of f prime. If they asked us to find mins, which I don't think they do, that would be here. Because, again, it goes from negative, the derivative, the value of the derivative goes from negative to positive. All right, so part B. Find all values of x at which f has a point of inflection. All right, so now we need to think about, okay, the second derivative. According to the, or in terms of the second derivative, when do we get an inflection point? Okay, so an inflection point is a point when f double prime equals 0, and remember, and the sign on either side of that point switches from positive to negative or from negative to positive. So an inflection point is like a max or a min, okay, or a relative extrema. Okay, the one word we use to mean max and min is relative extrema. Okay. So an inflection point is the same thing as an extreme. It means the derivative, the second derivative has to equal 0 at that point, and the slope, or the y value of the second derivative, has to change sign. Remember, the second derivative is the slope of the first derivative. Well, what do we have here? Well, this is a graph of the first derivative. So let's find all the places where the slope, not the value, the slope of the first derivative is 0. That's going to be here, and that's going to be here. Right, the slope of the tangent line is 0 in both of those locations. And then we just have to confirm. To the left and to the right, does the slope change sign? Well, to the left of this point, we have a positive slope. To the right, we have a negative slope. So that means that this is an inflection point. And similarly, we have a negative slope and then a positive slope. That means that is also an inflection point. So yes, if you were looking at a graph of f, just regular f, most of your first guesses would probably be correct. This would be an inflection point. But we're not looking at f, we're looking at f prime, and so that's why things are different. Part C. Find all intervals where the graph of f, not f prime, f is concave up. F is concave up when f double prime is negative. F double prime is the slope of f prime. So another way to say when f is concave up is to say when f prime is when the slope of f prime is positive. Okay, so f is concave up when f double prime is positive, or when f prime, when the slope of f prime is positive, or when f prime is increasing. Those are all ways to say the same thing. So f prime is increasing here. F prime is increasing there. And that's it. So anywhere f prime is increasing, that means the slope of f prime is positive. That means f double prime is positive. that means f is concave up. Okay? So make sure you have all those things in your head. You have to be able to go between f, f prime, f double prime, back and forth, and you have to be able to understand what each of those things mean in relation to each other. Because sometimes you'll get a graph of f, sometimes you'll get a graph of f prime, and sometimes you'll get a graph of f double prime. And then you have to be able to know what to do from there. And then part D is when the graph of f has a positive slope. So f prime is the graph, or is the function of the slope of f. So if they ask us about the slope of f, we're looking at it. When is the slope of f positive? Anytime we are above the x-axis. Right there. So from -5 to 3, and -3 I mean, and from 1 to 4. Those are your intervals. And that's it. Okay. So that's all we're going to do for today for the most part. Please just make sure you got it right. You understand why this is like this. The next thing that we're going to be doing is looking at more graphs. And you're going to get graphs of f prime, graphs of f double prime. And you're going to have to be able to tell this kind of information, get this kind of information from it. And then what we're going to do after that is I'm going to say something like, I want you to draw this graph. F prime is positive. F double prime is negative. And maybe I'll give you something about f, but let's just start here. So if we had a graph, and usually I would give you intervals for these types of things, but let's just do this. F prime is positive. That means that my graph has to go up, right? A positive f prime, if we're going to draw f of x. If f prime of x is positive, then that means our graph is always increasing. So that would work. But now it says, oh, but also f double prime is negative. Well, okay, my line's not concave down. So I need to go up and be concave down at the same time. There you go. There's a graph where f prime is positive, but f double prime is negative. And you can imagine how you might have to do that for, let's say we'll go from -4 to 0. This would be an x. Geez, that's disgusting. And then f prime is negative from 0 to 4. And we're going to do the same interval here, -4, x, 0, 0, x, 4. We'll say f double prime is now positive. So now we have a whole new situation. So let's redraw our graph and try this one. So here's -4 and here's 4. So from -4 to 0, we are increasing but concave down. So we know how that's supposed to look. And then from 0 to 4, we are decreasing but concave up. So that looks something like that. Is there a way to make that smooth? I don't know. That's how it looks though. That would be a perfectly fine example. So in addition to correcting your work, I want you guys to attempt to explain this graph in terms of intervals where it is concave up and concave down, or where the second derivative is positive or negative, and in terms of whether it is increasing or decreasing. So I'll show you what your answer should look like in a bit. Let's do something that comes like this and then does that. So there's your graph. If it helps, let's do that. Okay, so your graph goes up, it hits a point right there, and then it comes down. Let's call this, it doesn't matter at all, 6. Beautiful. So your answer should be from negative infinity to 0, f prime, and you can put either a positive or negative, f double prime, positive or negative. And if you want to use an arrow or a colon or parentheses, none of that matters. And then the next interval is obviously from 0 to infinity, and you're going to do the same thing. Okay, so this is the form that your answer should be in, and this is the graph that you're looking at. Okay, so I'll have a place for you to submit your answer to this question as well. That being the case, have a lovely Tuesday. I'll see you when I see you.